It's actually more absolute monster. It's actually climate I'm fighting with yeah, like yeah. Well, it's only because the person asked me. Yeah. Now I can't figure
Hi, everybody. Welcome to our first brown bag of the season. I'm Susanna Eden. I'm the Assistant Director here at the Water Resources Research Center, and I have the honor to present our speaker today. But first, I want to remind everyone who is here to please sign in, because we need to know who you are, and it also gives you a chance to get on our mailing list if you like. If you're new to this, to these forums. But regardless, please do sign our sign-in sheet. What we usually do is we'll go around the room and introduce ourselves so that our speaker knows who's here and who he's talking to, and we all know who we are. And so I'm going to introduce our speaker, and then I'm going to start over here, and we'll go around the room, and then Mike will tell us all about the El Niño. He's provided a very short biography, so you may have to ask him if you're curious about his deep history. Mike Crimmins is an applied climatologist and extension specialist in the Department of Soil, Water, and Environmental Science and Ecology, Agriculture, and Life Sciences. He's
Greg Nelson, most of the way, first year.
I'm John McKinney with Farmers Water and FICO.
Brittany Hugh, Water Resources Research Center.
I'm up the clock, also the Water Resources Research Center.
Jacob Fredo, hydrologist, in kind of
We go around the outside and then come back to the table.
Okay. Betsy Wilkening with Arizona Friendly Flood for WRRC.
Joe Conner, School Natural Resources.
Ian Shire, School Natural Resources and Institute Environment.
Mary Black, I'm with the UA Center for Climate Adaptation. Sharon Medfield, Water Resources.
Jay Cole, evolutionary biologist, and my wife and I will harvest untreated rainwater.
Carol Townsend, I'm his wife. Interested citizen. I'm detailed citizen.
Christine Olin, currently with the University of Texas at Austin.
Mark Berlitz, public health.
Julie Booger, I'm a research social scientist with Institute of Environment.
Doc Clarkson, PhD student, soil, water, and other things.
Rob Root, Research Professor in Soil, Water, and Environmental Science.
Kimberly Nelson with USGS Arizona Water Science Center.
I'm Susan White, I'm a retired middle school math teacher.
Nick Thompson, Tucson.
I retire, I'm a hydrologist.
Ashley Bollinger, Water Resources Research Center.
Dylan Huber-Heidorn, Master's Student in Urban Planning.
Hi, I'm Jeannie Bander. I'm the librarian liaison to the College of Ag and Life Sciences.
And you just came in, you just made it in time to introduce yourself.
Vincent Poloski, a recent graduate, in the University of
And before we get started, I just want to alert folks here that about a little over a year ago, Mike gave a brown bag about the monsoon. And he let us know at that time that he is obsessed with El Niño phenomenon. So, so this should be fascinating to hear about his obsession.
Therapy for me more than anything. Thanks, everyone. So I also remember as I wrapped up, this was in July of 2014, Sharon, I think you gave me the award for the most colorful presentation. I had the more colors in most slides, I think, than most people. So I took that to heart. I'm going to try to up my game today. So there'll be new colors that you maybe have never seen before on this presentation. Okay, so when I last gave this talk, it was actually in the middle, actually the beginning of the monsoon, and you kind of put me on the hook to try to give a prediction of how the monsoon will turn out. And hopefully everyone has forgotten what I predicted, and we all just know how it turned out. And thankfully, you put me in the slot at the end of the monsoon, so all I have to do is sort of talk about how it turned out rather than predicting it. And you gave me the kind of the easy job of making a winter prediction because of what we're going to talk about today. So I'm going to basically take the same strategy as I did last time and split this into 3 acts here. We're first going to talk about the drought, where we're at, potentially how things have changed more recently. Then we'll bring it right up to the present, what has happened with this monsoon season across much of Arizona. And then we'll jump right into trying to answer the question that's on everybody's mind. El Niño, Godzilla, or Mothra? What kind of El Niño are we going to be heading towards? So we start off with the sort of classic first step when we start to talk about the drought here in the United States is we use the U.S. Drought Monitor. And does anyone follow this product? Every Tuesday we get an update. It's done by a group of experts around the country, rotating authors in different agencies, different parts of the United States, listserv discussions. Something interesting has actually sort of happened with the drought monitors. We look at the Western U.S., and I don't know if anyone has picked up on this, is that there's now this black line moving around. It's basically encircling much of the south. I'm going to try to do my. I think I got it right here. So I'm going to try to do this for everyone here at home. See what my joystick skills are. They're pretty rusty. But this black line here is a designation, a shift in the type of drought that's now trying to be depicted by the U.S. Drought Monitor. And these little S's and L's are actually pretty important and critical in understanding what the Drought Monitor is trying to communicate. The S stands for short-term drought. The L stands for long-term drought. We used to have a combination of S and L across Arizona and much of New Mexico for that part, which has largely subsided over the last year. And that's what we're going to look at, is that we've had several months now where, and even runs of months where we've hit average precipitation, which I didn't think was possible in Arizona. In my 15 years here, I've lived through mostly drought, and I just figured that that was all this place had in store for me. But instead, we've actually started to accumulate some near average to even above average precipitation at certain times. But again, this is over a period of 6 to 12 months, maybe 18 in some periods, which is enough to sort of push back short-term drought conditions, getting precip in the right seasons. But again, the long-term drought situation is still here.
That average you're defining is over 30, what years? 100-year average?
Sure, yeah, at least 30, often 100, depending on what location you're actually at. So we've now had this shift across, and you can even see here that New Mexico, parts of it are drought-free, thinking about what had happened there just 2 years ago. I would argue that there's probably still some lingering drought impacts here, but they've been maintained largely on this drought map by this L designation. Okay, so that's something to talk about, I think. And so this is a 4-panel image here of the drought monitor map going back to just about a year ago, moving forward about 3 months to December. This is March 17th of last spring, and then this is right at the beginning of the monsoon season. And if you notice, the first 2 panes here, after September 16th, we were still sort of reeling with some very heavy rainfall. We weren't sure exactly what to do with it from a drought monitoring standpoint. You wipe out the drought, you keep it in there because of long-term impacts. A lot of us argued that you just can't erase a drought with 6 inches of rain in 6 hours, and I think that that's true. So we held on to drought conditions in certain pockets and areas across Arizona here. And you can see there's this patchwork here of extreme drought, moderate drought, severe drought. We get to December, not much change. Actually, I don't know if you can spot change on there. This is kind of a fun game. You go on to here. There's a
Virgin River.
Virgin River? Yeah, look at that. I can't really do this with my joystick. Look at that. That's precision right there. We carved that off there. By the time we got to March, remember last winter wasn't all that spectacular, but we had precip, largely rain, very little snow, some improvements across Arizona. The lower Colorado had some improvements because of some precip. And then we get to the beginning of the monsoon season just a couple months ago, and we've knocked back the extreme drought, and we've got this patchwork of moderate to severe and some abnormally dry parts of Arizona. So we've actually moved in a direction of improvement over the last year, which is cool. We should definitely celebrate that. What does it actually look like over the western U.S. over the last 12 months? So this is not quite the water year because we're not quite done with the water year. So I just backed it up a month. So this is the beginning of September of 2014 to the end of August, just a couple weeks ago. This is percent of average precipitation. So whites indicate you hit the average for that 12 months. Greens, blues, light blues, and blues indicate above average, more than that, 100%. And then below that, the yellows and reds indicate below average precipitation. So you can see here that the western U.S. has been sort of cut in two here, and it's almost right, very interestingly, right along the Colorado River here of the haves and the have-nots. And California really struggling through this last year in their 4-year drought, with some places less than 45% of average, so less than half of average over even the last sort of water year. This is my sort of water year portrayal. As far as temperatures, you can see too that there's a bit of correlation between where it was wet and where it was dry and what the temperatures. The whole West was above average, several degrees in some instances, depending on where you're at here in the West. And again, right along that Colorado River line, Arizona was above average, anywhere from 1 to 2 degrees. But a lot of these interior sections along California and Oregon and Washington were anywhere from 4 to 5 degrees above average, which that coupled with dry conditions, coupled with very, very little snow, if there was snow, it didn't have much of a chance this past winter because of these temperatures. Okay, so we sort of zoom in. This is the beginning of graph craziness. I just want you to know, I don't know if you're hoping for a slide of words, but they're not going to come. This is, again, and keep tag with the color bingo as you get all the colors on these particular charts. You could win a prize by the end here. But if this is for the, this is now with the water year ending just through yesterday, I think is when I pulled this graph together. Daily observations at the airport. And what we have here at the top graph here is the min and max temperature observed back from October 1, 2014, all the way through the year, right up until, I think, yesterday or the day before. Okay, and so you can kind of see here how things have stacked up as far as temperatures here. The green band in the middle here is average high and average low. The blues indicate where you're below average to record average, below average, when you get to the bottom of these bars. The reds are the record high for the day. And you can kind of just sort of plot through here and see what kind of year we've actually had. And you can even remember back to some particular events. Here was this very warm period we had in beginning of March. There was a freezing event that I remember hit southeast Arizona right in the middle of April that caused quite a bit of damage after this really intense warm-up. So this sort of interplay of very warm spring followed by a pretty typical climatological freezing event caused some damage. Here is a very interesting period here from April, the end of April, the end of April through most of May. If you remember back to that period, it didn't get warmer every day as we went through the spring. It actually stayed the same temperature and actually got cooler through the end of May, which was the first time I had ever seen anything like that. I thought we were just going to skip summer because we already had it in the winter. Maybe sort of a conservation of seasons going on. But that was again, not going to happen here. And we end up going through a very cool and a very wet May and jumped right into summer by the end of the month. Had another very set of strange events of some tropical storms visiting the Southwest in early June, dropped temperatures down, had set rainfall records in Phoenix, 1/100th of it. I think it was actually a trace. A trace broke the record of never having observed precip on a particular day in the beginning of June. So when the records are on the floor, they're easy to break. And then we move into the end of June. We get summer on in full swing. July turns out to be a very, very normal-ish month as far as temperatures. And then we bob back into the record heat of August. And then now we've been on this sort of nice slide back down with a couple of really wonderful days with some gray, cloudy skies that you don't normally see in the middle of summer. So really just a wonderful mix of everything that Arizona has to offer just in a couple of months. And then on this bottom graph here, this is cumulative daily precipitation. And I believe this is the first time I've ever seen this since living here. But when the daily total cumulative precip is it rains and then you add the next day to the next day to the next day, so you keep moving up. It'd be just the same as if you went out and looked at your rain gauge and never emptied it. It would just keep getting fuller and fuller and fuller. That's what's happened here since last October. This was actually a little bit of tropical storm activity with Simon, a slowdown here. But we've stayed above the curve almost every day right through the water year. We've been ahead of the curve, actually. So right to this, just yesterday or the day before, we're at 12.53 inches, and the normal to about this time of year is about 11. So we're actually above average. Again, nobody freak out. Yeah, I know. Okay, so that's all really amazing and impressive. Okay, so if we look at this in sort of map form, this is the last 6 months. This is the standardized precipitation index. Another way of scaling this information. So 0, these are standard deviation units, if you remember your statistics. So if you're at 0, you're at the mean, you're at the average for the 6-month period. If it's green, you're one standard, I'm really having trouble driving this. 1 standard deviation up to 2.5. So if you get to the more blues, you get into a wet situation that's very rare in a 100-year record. And then down here with the reds, very rare in the dry. So you don't have to squint your eyes too much to look at this map and say, there's not a lot of reds on this, if any. There aren't any. There's a little bit of yellow, a lot of white, meaning we're hitting average, and some blues. So overall, the state in the last 6 months has been above average. And a lot of that actually came in late April and May. In May, a very, very oddly timed precipitation to boost overall precipitation. So a weird couple of months, but really sitting pretty good as far as short-term drought. If we stretch this time period out and we look at the last 3 years, that's where you start to pick up some more of those dry periods and you move it forward with you. So that's also the part of the game we have to do in Arizona. So we can't just think about what happened today or yesterday. We've got to think about this on longer time scale because that's how water responds, that's how trees respond. It's a much sort of slower varying, longer term elements of climate. But even at the 3-year time scale, we're still moving in the upward direction, moving into improving territory, moving out of drought even at longer time scales. So it's both heavy and extreme events and short time scales, but they're stacking up over time and adding together to lift the whole longer term drought situation and moving it in the right direction. I didn't think I'd ever have to be able to say this in my career here, working in Arizona. I had been preparing for drought, and now I've got to actually figure out what to do when drought doesn't occur anymore. Well, something else will do. Okay, another sort of abusive color-rific graph here, very trippy. But this is basically the same kind of information here, this 36-month SPI. Think of this 36-month SPI and the 6-month SPI being represented on the same chart at the same time. So the 36 is now a slice in time this way. Now we're looking through time for the whole state of Arizona, and the 6-month is right down here. We can look at all of those time scales of drought at those different windows from very short term, from just the last month to the last 6 years going backwards. And anytime it's white to green means we're average to above average. We're in those wet conditions. Anytime it's sort of yellowish to dark brown is when we're in those drier conditions. And the point of this graph is to communicate this idea that we can have both short-term good conditions from a recent wet period, but also have this long-term drought persisting. But what you notice, and it's hard to see in this graph because it's moving towards this white color here, but right now for the state of Arizona, all these greens mean at the shorter time scales, all the way up through that, what we were looking at that previous graph, 36 months, are now moving to average to above average. And then above this is when we get down to the 4, 5, and 6 year time scale, we still have those dry years sort of in that window, but they're getting left behind. And as we continue to stack up these little green bars, which are above average months, you can start to build short-term and long-term lack of drought as you go forward. So that's what we're looking for, is not only just a wet month, but can you have a wet month and then a run of wet months going forward? And I think we're going to be able to pull that off in the next 6 to 8 months. Okay, and that's where the story starts to move forward here into what has actually just recently happened. All right, so again, more maps. And as I talked about last year when I gave this back, a little bit of the mechanics of the monsoon. If we completely simplify it down into, what's sort of the main working parts of the monsoon system, it's really the position of the high pressure system, the mid-levels of the atmosphere, that sort of help direct moisture into Arizona. And so this is a weather map at about 20,000 feet in the atmosphere. And the red colors indicate high pressure, the blues indicate sort of lower pressure. And we look at for little waves on this map to indicate where the highs and lows are. And so this is July, the average weather conditions for July. This is our monsoon ridge right here. And this is a little trough of low pressure that's been hanging off of the California coast. Okay, and as we move forward, you can see there's not a lot of change throughout the summer season. That little trough hangs off the California west coast, near California, and the monsoon ridge is actually displaced and a little bit weaker than we would like to see. So this is actually kind of interesting. So as we went into this monsoon season, we saw this El Niño event picking up steam, ramping up into record territory. And usually what that spells is misery for the monsoon season in Arizona, because what it does is it creates a pattern similar to this. And if you look back at past events, when you have the ridge sort of displaced and weakened, you typically, all you end up doing is dragging in dry air here and killing off the monsoon convection. Well, what happened, which was a little bit unexpected and thankfully was the case, is that there's been so much warm water and humidity down here that this flow actually turns out to be really effective at pulling. And you can see here, remember, it's clockwise around the high pressure system in the northern hemisphere, and counterclockwise is these two little wheels of the low and the high have been funneling moisture up into Arizona. And that's been really effective, at least socking us in with moisture. And then if we can get a little disturbance or we can get enough sun and we don't cloud over, we can actually form storms. And we've done that quite effectively throughout the whole monsoon season. So this will be one of those instances where we think, or we thought, that El Nino events gave us not a clear forecast, but some leaning towards a drier than average monsoon. And this monsoon is almost perfectly on average for most parts of the state. So it's one of those little flies in your statistical correlations that you're going to have to explain away in the method section. But we'll take it, right? This is how the state has shaken out. This is the 15th of June all the way to the 12th. So just a couple days ago, the data were updated. And it's not washed out. Actually, what it is that if a particular spot for this monsoon period is at average, it goes to white, okay? And anything that's brown is below average, down to 50% of average or less. And anything that's green is above. So it's, again, the same sort of way of representing the data. But if you notice, a lot of places have sort of settled into average conditions. So we're heading towards the end of the monsoon season now. Technically or officially, we're going to be done on September 30th. But for all intents and purposes, we're probably done today. Yes?
It looks like there's a couple of dots where you have data, and when you don't have data, do you just
It's interpolated.
interpolate?
Yep, it's interpolated and adjusted against elevation. So it's got gauge network and then regressed against elevation.
So that could explain why it looks a little bit dotty.
Some of those are definitely where there have been raining on particular gauges. Yeah, absolutely. Yeah, sure.
So I think that's through November, I think September 12th.
Yeah.
Is that the date?
Yeah.
I heard you might have like 4 inches of rain next week. You don't have a 6 million, or is that a blue dot by Yuma there?
It's right here. I don't know if you can see this, but it's now above average. So Yuma had recorded no precipitation up until a week ago. They had 0 rainfall, and then they got it all in 2 hours. Yeah, yeah. And so they hit their monsoon average. This spot north of Yuma actually got 4.5 inches of precip, and so they're now at their annual average. So that's how you do it in the lower Colorado. Yeah. So they did it. They had this whole lower Colorado had been below average up until a day, and then it switched, and that's how we do it in Arizona. Yes. Yeah. So there is a patchwork. There are some local heavy rainfall events. Some are interpolated in. Some have actually been caught by gauges. But you do get that sort of spotty patchwork out here. It's easy to get above average here because the averages are so low, which is why you end up getting sort of this pockiness here. Here, this area has had frequent precipitation, relatively well spaced out, and has settled into near average conditions. So we can look at this map in a time series way. So remember these colors. So blues are above average. Greens are, well, say very much above, highly above average, very above average. Greens are above average. Whites are average, and then browns are below. This is a stacked bar chart going from the 15th for the whole state of Arizona. What's the area percentage-wise going for just the last couple of days? So you can see here, at the beginning of the monsoon, a couple of spots got hammered by early precipitation, and they went above average. And then this was our big ramp-up period, the last bit of June, where it just started to rain everywhere and rain consistently for about a week. And then the whole state started to fill in, and we went to about, let's see here, a little over 60% of the state was above average or better, and 40 was below. And then since then, we had a slowdown in July, a big ramp up with a couple of events towards the middle of the month. And then since then, we've kind of hit status quo, which meaning that either an area has just picked up so much rainfall and was so far above average, it's just been waiting to settle back in. Like it hit its monsoon average early in the season, didn't get any more rainfall, so by the end of the season, it's just average. That kind of makes sense, because if you hit it early, you can be way above average for the season, even though the season's only a couple weeks long. But by the end of the season, where you've expected to get a whole lot more, you just haven't, so you just settle back into the average. Part of it's that, this sort of maintaining of the area of average has been largely just getting frequent precipitation on pace with what you'd expect with the monsoon season. So to me, I jokingly have given this monsoon a C+, because it's not overachieving like it was last year, but it's not phoning it in. It's like it's kind of showed up, and it shows up at the last minute when I get real crabby about it. Like just a couple weeks ago, we were so down on the monsoon, it wasn't raining here in town, and then boom, it floods out in Midtown or something like that. Like it could hear you and you're grumbling, saying fine, and it would do it, and then it would just slack off for a couple of days. That's kind of been it the whole monsoon season as we've gone forward. A couple more plots here, and I'm going to show a couple of these. These are station level plots throughout the monsoon season, and this is just to sort of articulate that. This is from 6/15 all the way through September 30, so it's not quite done, but this is at the airport for this year, and you can see here how this is one of those slacker times where the monsoon's like, it's getting lazy, and then it says, okay, here you go, here's 1.5 inches at the airport, and it won't do anything other than getting itself back up to average, right? I'm anthropomorphizing the monsoon, which I feel like we should do with all climate phenomenon, so we have a good relationship with them. And then here it slacks off again. Okay, here you go. Here's a couple more. And then it puts us right back on average. So it's not, again, C+. I'd say C+ for this activity. You can see here on the stats here, we're at 5.1. On average, we had about 6. If it's really going to get a B-, it could show up and turn in the rest of its homework and get us right up to average over the next couple of weeks. I don't know if it will or not. The number of events is about 23, which is just shy of about 25 we normally see. And the amount of precip you get during these events is almost on average. So it's like it is the standard monsoon, even if it hasn't felt like it, which has been kind of the weird things about it. Phoenix, a little more active. Same thing, same kind of events here. It is slightly above that. Well, it's actually hit the long-term average for Phoenix, and it's got a couple weeks to go. Slightly more days than it normally rains, and slightly on average intensity. So even for Phoenix, pretty average. And then for Flagstaff, spent some time in sort of B territory, but it's really started to slack off again, back down to, I'd say, C+ activity. And again, very, very close to the average as far as activity going forward. So, I'm happy with it. It's decent work. We'll take it. And coming off of really great summer last year, mediocre winter, crazy spring. Maybe it's felt like it did so well in May, or did so much sort of extra credit or sort of prep work in early June that it didn't have to kind of work real hard. I'll take that, because we are still sitting above average with our precip. Okay. The thing was kind of on our minds this year, and frankly still should be on our minds, is the East Pacific is still roiling. Even though we're not hearing about it every day in the news, it's been a very busy season as it was predicted. Here, the total number of storms in the East Pacific is 17, and on average, we see about 10. And as far as major hurricanes, we've seen 8, and on average, we see about 3. So it's been a very busy year. But you can see that most of the tracks have been south and off to the west because of the position of the high. And there's actually been quite a bit of shear in the East Pacific, so this hasn't been a real favorable area right here for formation. This was favorable early in the season, became less favorable, and you saw more of the activity sort of further south and then further off to the west with all its very warm water from El Niño. And Hawaii has been on the knife's edge all summer, waiting to get hit again, which is very, very unusual to have this many storms come that close to Hawaii. So still, this is in play through, you could say much of October, but probably sort of the middle of October. This is still on our doorstep. So this would be sort of like the monsoon coordinating with the tropical storm season to just like come up and say, I'm going for the A+ at the last minute. And that could certainly happen, given that we've moved into a transition. Okay, so here we are. We're now to the El Niño part of this. And so we'll just start off with the El Niño to Godzilla scale, which I'm so glad was actually developed this year. I hadn't seen it in the literature until this year. And you can see that we've actually pegged it at the Godzilla scale. And these are all of the monsters here. And this is the one, I remember these as a kid. But there's Manila, which is the baby Godzilla. And so I was going to title it, is it going to be a baby or the monster one? But we are definitely in the monster territory. And if has everyone followed the reason why I even put up Godzilla or Mothra? Okay, good. I figure the hyperbole has sort of drifted down to everybody from the news. And I think that the scientists who used the Godzilla term got done with the interview and said, "What have I done?" He's like regretted it. And I can convince, he's a NASA scientist. He can trace it right back to the source. And I'm going to guess that the next day his office was full of Godzilla crap that somebody had brought in and papered it. And it's carried through and is even have these memes that have shown up on the internet. Okay, so I thought it would be useful just to step back again because we so rarely talk about El Nino. We haven't talked about El Nino regularly here in well over 20 years, and we've only really had one decent event in 2009, 2010. So we've been in sort of persistent neutral to La Nina conditions. So it's probably worthwhile just sort of revisiting. Okay, what the heck is this thing? Okay, it is not a monstrous phenomenon, even though I like to give it sort of a persona. It won't storm ashore creating waves and then step on things. It's actually a climate phenomenon. It's a climate timescale phenomenon, and it's related to the global circulation of the planet here. And if you remember back to your physical geography here, the easterlies are the dominant wind flow at the surface around the equator all the way around due to the global circulation and the Hadley cell circulation. Okay, and when we have persistent low-level easterly flow across the biggest water basin on the planet, huge geography. If you look at a globe and you kind of trace your finger around it, it's amazingly large expanse of water, right? And it's baking in the sun. So wouldn't you expect then that would be very, very warm water that would decrease with lines of latitude? Just very simple sort of isotherms from north to south along lines of latitude. That is indeed part of the story, but these easterly winds do a really interesting thing, is they frictionally push the water from the along the equator from the the western coast of South America and move it along the equator, causing it to build up in the far western Pacific. And so conservation of mass means that there's got to be some water to flow back in to replace that water that's being pushed away, and it flows up from deep. So you get this cycle of water and movement of water that's cool, upwelled water in the eastern Pacific and warm, sun-baked water in the western Pacific, and you get a temperature gradient that exists. And there's sort of a magic isotherm or magic temperature line that exists with tropical sea surface temperatures. About 28 degrees Celsius is the temperature you need to reach to create thunderstorms above it. Okay, and if it's cooler than that, it's not very effective. And if it's way cooler than that, you just don't have any sort of thunderstorms at all. Okay, so where this warm water is has everything to do with the type of weather that occurs over it. And what we see here is that this warm water, when it's typically over here, creates thunderstorms, rising air. What goes up in the atmosphere must come down. We have another circulation called the Walker circulation with low-level easterly flow, rising air, and upper-level westerly flow. And then the air sinks again, coupled with the Hadley cells, back over in the East Pacific or the Caribbean, depending on where this Walker circulation is sort of strong and set up. Okay, so that's normal conditions. So you can see here, this is actually a dynamic system. The sea level height in the Western Pacific is actually tens of centimeters higher than it is in the Eastern Pacific. Okay, so it is actually dynamically unstable in some respects, hydrodynamically unstable. Gravity wants sea level to be the same level, right? So this circulation has to be consistent enough, and it's warm water too, so it's isothermically, it takes up more room, has to be sort of sustained. Like if the winds stop, you're going to have some sort of dynamic response, right? So that's exactly what happens. When we get into El Nino events, and this is where the science is really interesting and completely unclear, is how do El Nino events start? How do they stop? And what keeps them going isn't terribly clear, even to this day. Lots of climate controversy within the literature among scientists about this method versus this explanation or these sets of equations versus this conceptual model, but not completely locked down. And if it were locked down, boy, we'd be a lot better at predicting these events, which you may have noticed we're not perfect by any means watching this event unfold. So again, remember this warm water, which is higher sea level height, the easterlies, which are holding it there, slacken, and you get a literal sloshing of water. And we can see them on satellite. We can see them in observation called Kelvin waves move back up along the equator. They're trapped along the equator because of the Coriolis force, and slosh back and bring the warm water with them to the eastern Pacific. And if this water is warm enough, the storms come with it, and you can envision then the whole Walker circulation changes, where the rising air and where the sinking air change. And so now if we have this rising air now in the middle, the central, the eastern Pacific, spreading up here, we have sinking air, and you can see where this is sinking. It's sinking in the Gulf of Mexico, the Atlantic. And think about sinking air. Have you noticed anything about the Atlantic storm activity this year? It's been almost nil, right? Largely because of shear and sinking air because of this redistribution of convection along the equator. So it all sorts of fits together here. And this is this cross section here too. This is the thermocline. So when we talk about the warm water is basically a lens that is on the top, right? Because warm water is above colder water. And if you jump in your pool after it's been sitting in there, you know this, right? It's warm at the very surface. It's cold down below. It's exactly what happens in the ocean. And where it very quickly goes from warm to cold is the thermocline. And so this whole thermocline flattens out, and you get this lens of warm water across the whole Pacific Ocean. Okay, so that's the El Nino situation. All right. This is the activity of El Nino over the last, since 1982. This is a measurement of how warm it is in a certain part of the Pacific Ocean, which I'll show you. And this is just to illustrate how it's not a perfect sinusoidal oscillation over time. It doesn't have perfect predictability, quasi-periodic oscillation. And you can look here, what are the big El Nino events of the last 30 years? 1982, 83, and here's a 97, 98. We've had one in, believe it or not, 2002, which was right after this sort of drought-inducing La Nina event here. Very middle ground, very weak El Nino events, pretty lame. 2008, here's 2009, 2010, which was the last decent El Nino event we saw here in Arizona. You might remember it. It started off decent in December, very heavy rains, 10 inches in Globe, 10 feet of snow in Flagstaff in January. Quickly subsided. You can see how sharp. And then we went into a La Nina here, and then Flagstaff caught on fire 2 months later. It was a classic Arizona, how you can do it. You know, both extreme snow and then extreme fire within several months. And then this is sort of the drought conditions that have plagued us since. And this is the flip around here, and this is the march up we've had in El Nino conditions right up until present. So it doesn't look like these sharp peaks of 82, 83 because it's been a little bit of a different event. Okay, and so why do we care at all what happens in the Pacific Ocean? It has everything to do with the storm track and the jet stream during the wintertime. And we happen to live in a spot on the planet, not every place is impacted to the level that we are, where the jet stream changes and tends to steer storms on a more regular basis into Arizona, which is why when we hear an El Nino event stacking up, and one of this magnitude, we expect to see a certain type of weather pattern set up through most of the winter, and that's indeed what the case is here. And so this is just showing you the sort of Pineapple Express funneled at the southwest and through the southern third of the U.S. And this, I apologize, this is really hard to see, but I wanted to articulate how subtle this is as far as what the jet stream looks like. This is at 200 millibars, so this is about where jets fly in the atmosphere. This is the coast of Asia here. This is the whole Pacific, the west coast of the U.S. There's a jet stream that forms typically, this is December, January, and February through the middle of winter here. And there's another one that forms here off of the east coast of the U.S. And think about the water's very warm, the air's very cold, the jet stream will respond to those temperature gradients. Here is the La Nina event of 2011, which was a miserable year. And you can see here that the jet is a little bit shunted back towards the west. There's this crazy loop here. This is the part of the ridiculously resilient ridge over the western U.S. And the jet here is even a little bit weaker and displaced. So this is a situation during the winter where the storms go far north, up over British Columbia, and we just sit here with beautiful, sunny, warm skies and wait for it to rain in the summer. We just write off the winter and just say, okay, I'll just wait till the monsoon shows up. Okay, this is the last big El Nino event of equivalent magnitude we're talking about now. This is December through February of 1998. You can see here, compared to La Nina and what's average, look how much bigger and stronger the jet stream is down here. The colors are much richer and deeper. It extends much, much further west, and the jet stream is actually right at our doorstep. The closer the jet stream is to you, it's going to be an indication of storm activity and really good energy flow to actually drive those storms. So that is what you should expect during a typical strong El Nino event going forward. And you can see this is a global phenomenon here. It's not just the Southwest that deals with this, but this has implications around the globe, both good and bad. Largely bad, you're talking about flooding in sort of developing countries or epic drought here in Indonesia. Okay, so now let's just take a look at a couple of the past relationships of El Nino strengths and what happened as far as precipitation. Okay, so I'm going to show you two different parts of Arizona here and how this stacks up. And I won't dwell on these too long. So this is October through March, total precipitation on this axis for southeastern Arizona. And then along this axis is the strength of either a La Nina or El Nino event. So blues are La Nina events, greens are neutral, reds are El Nino events. Okay, so what do you notice as far as the organization of these dots kind of going forward? The blues all tend to be below average or on the lower end of the axis, right? So La Ninas typically relate to drier winters almost very consistently, especially for the southern part of the state. There's only a couple of instances of average to above average precip here, but most La Nina winters give us below average. It's a pretty good forecast when you know La Nina is coming because of that jet stream. In neutral years, when we don't really have an El Nino signal, losing my pointer here, the green dots give you typical Arizona, which is everything from the wettest year on record to near driest year on record, which is Arizona, right? I mean, it can throw anything at you in any given instance. Now, when we move into El Nino territory, we start to now see with the stronger events, they get much fewer. This is 1950 through 2015, through last year, is that they tend to now start to move up into above average territory. They're not necessarily the wettest years on record, but they sort of cluster in this sort of decent level of above average precipitation. And that's about all we can really say going into this event. It does not suggest that it will be a Godzilla break everything type winter. It does suggest that it'll be above average. It sounds so unexciting, but to me it is exciting, right? Above average sounds great in this instance. And this is southern Arizona. If you move up to northern Arizona, it gets a little bit cloudier. It's not quite as clear. The El Ninos start to take up more of the average space. They're not as much of a slam dunk forecast. The green neutral events have the same spread. And the El Ninos do cluster slightly above average, but it becomes less clear. And that's also what we know. As you go north in the western U.S., the relationship between El Nino and wet conditions decreases to the point where you get up into Utah, it's almost a wash. El Nino or La Nina don't tell you anything about whether or not you're going to have a wet or dry winter, which is from a water forecasting standpoint. There's a bit of ambivalence with this event. It's only when you get down into sort of Arizona, even northern Arizona is a little bit of a wash, but even Salt River is certainly paying attention. The Colorado River, north of here, it's not as clear of a forecast as we go forward. As you can see here, though, this is the forecast strength of this upcoming El Nino event. Right here is this red line. And you can see it is just inching out 1998, and it's in very rare company over the last 60 years. So it's really a question of where does the next red dot get entered on this graph? Most likely, probabilistically, it will be somewhere close to these guys. Could be a little bit higher, it could be a little bit lower. It's a very low probability it'll be down here, which is the way all of the forecasts are structured, is they're probabilistic, and I'll show you what those numbers are. Okay, so this is the game now is to compare. I won't dwell on this slide. This is 1982 as far as the temperatures. Just focus sort of on this middle graph here. These are big events. We look a little bit stronger than 1982, not quite as strong as 1997. This is through August. So we're definitely in rare company right now. which is part of the excitement. This is the way the whole Pacific, it's record warm in many parts of the Pacific Ocean as far as the last 100 years. And most strikingly is the North Pacific, and right off the coast of Western North America is the temperatures there. These are the forecasts going forward now, okay? And so when you get up to, so 0 would mean a neutral event. This is, again, what we're doing here is we're forecasting what is the temperature, the average temperature going to be in this box going forward. Because we want to know if it's going to be really warm there and warm enough to support thunderstorms, it's going to have an impact on global circulation. And if it isn't, then it won't. So these numbers are the average temperatures in that box. And when you get up to about 1.5 degrees Celsius in that box above the long-term average for the wintertime, you are in strong El Nino territory, rare territory. And you can see here that all of the forecast models here, the North American multi-model ensembles going forward have us well over a degree, half a degree to a degree above a strong event, all the way through next spring. So it's locked in. For all intents and purposes, it's not going to shift back. We are locked in. The expectation is that we will see some kind of impact from this event. These are the forecasts now going forward. Green indicates where the probability is shifted towards wetter than average conditions. And so you can see here, this is November, December, and January. 3-month average is here. You can see it's just slightly above average here for Arizona, which is also another interesting thing about El Nino, is that we typically see the strongest impacts in Arizona later in the winter, not as much during the earlier part of the winter. The earlier part of the winter does seem to favor sort of Mexico and the southeast U.S., which is why there's only a slight shift in probability here. And as we get down to January, February, March, we start to get into the deeper greens, which is when the more reliable signal emerges. So if it's not pouring down rain on Thanksgiving or Christmas, don't freak out. We still have a chance to hit our average to above average precip, and it typically happens late in the season. Okay, these are the official forecasts. You can see here, this is November, December, January. Again, the early part of the season, near average temperatures, which we have not seen in a long time, especially in a winter season. And this is that slight shift in odds towards above average precip for that 3-month period. And then we get here into January, February, March again. We are now just on the edge of slightly below average, because typically as it gets wetter and there's more clouds, we have less sun during the winter, which is just enough to bring us below average temperature-wise. That's all it takes here is some clouds. You can drive your temperatures down. But look at this, this shift in the odds here over southern Arizona and southern California. It's a 60% chance of above average conditions for this 3-month period. So it's January, February, March. Okay, so these are probabilistic forecasts. So 60% chance of above, 33% chance of average, a 7% chance of below average precip, what that suggests. Okay, so even just hitting average or above average, there is a 93% chance of hitting average to above average precipitation during this 3-month period. Have you ever heard of a forecast that strong? That's amazing. So that's a big lean right here for this late or mid to late winter period here for southern Arizona. And again, is when you'd expect that storm track to just sort of settle in and give you a delivery of storms day after day. Okay, so I'm going to wrap up here with some comparisons. What did these past events look like as far as precip across the West? The top here is October through March precipitation for 1983. So this is the last big event. The green here is the top 10% of years for the last 115 years. So if it was green on this map, it means it was the wettest 15 years. And if it was dark green, it means it set the record for this period here in time. So this is 1983, and you can see that much of California, I'm not making a forecast for California, they're on their own for this one. And then here's 1998. The pattern is very similar between the maps. The magnitude is different. And that's often what you expect to see with this dominant storm track coming across the Southwest. And I just wanted to wrap up with a couple of slides here. These are just like the monsoon graphs I showed you, but now they're for the wintertime season. And they run from October 1st all the way through May 31st. So they wrap the whole cool season. But I wanted Remember the one that broke all the pipes everywhere and that kind of stuff, right? So that was that particular winter. It did not rain a lot. And that was the point of this graph, is that we had 1.47 inches over this very multi-month period where we should have seen about 5.5. We had very few rain events. The intensity was very low. We ended up with a huge deficit, which was a La Nina winter. This was a strong La Nina winter, and this is what strong La Nina winters look like. Okay, so let's flip this around, because I haven't seen a big El Nino event here, so I wanted to compare my memory of this event, what it looked like, to what an El Nino event looks like. This is what an El Nino event looks like. So this is 1982, 1983 here for Tucson. And again, it's got that same thing we were just talking about here, is that it actually started pretty slow. November and December had some activity, but the big jump in precip in 1982-83 happened from February through much of April. So think about it raining through April when it's usually done by March. That's the weird thing that can happen in shifting of these events. And so this is 1982, 1983, and then this is 1997, 98. You can kind of click back and forth. They're pretty similar in sort of the pace and the activity here. December, it's a little bit slow here at the beginning, but then big burst in activity right at February, and then big runs of multiple heavy days occurring February, March, and April going forward. So, but again, the problem with small numbers is that two events that look similar doesn't mean the third one is going to match up, right? So that's the caveat emptor of this whole thing. But hey, two is better than none to compare to. Just going to skip that. Okay, so this is to wrap up here. I got this off of John Fleck's blog recently, and this is the natural inflow into Lake Powell, just to reinforce that point I was talking about here. Think of those scatter plots of precip we just looked at. This is stream flow, spring stream flow into Lake Powell versus the El Nino here. And you can see here it's just a scatter shot of events. So it does not give you any sort of clear indication of what will happen as far as stream flow in here. But you see things like 1983, and the great stories that happened during 1983 with Glen Canyon Dam. But you also have events like here, like 1998. Believe it or not, 1998 gets classified as a La Nina year on this graph because it went from a strong El Nino to a strong La Nina in a couple of months. And by April, we were already in La Nina territory that year. So this year actually gets logged on the graph as a La Nina event because it was such a short event, but punchy. So it doesn't tell us a lot on that element of it. Okay, so just to wrap it up here, the short and long-term conditions continue to improve. The temperatures continue to run above average. So it's this thing of keeping an eye on temperature and drought impacts, still an area of research we really need to figure out, is that if it gets wetter, but it's still warmer, are we actually getting improvements in drought? Some things, yes, and other things, probably not. Don't fear this event. Embrace this event. This event is a really great chance, greater chance than we've seen in probably 15 years of having full rain gauges by March, right? And using your galoshes, if you even have some or own those or even know what those are. Get a raincoat. This is probably the year to shake it out, see if it's not cracked. I actually had to do this recently because mine had rotted in the closet. Umbrellas, clean out your gutters, anything that you can take advantage of knowing ahead of time that it'll probably be wet by the end of the spring. This is the time to do it. What you'd expect from this is more rainy days. Some of them will be heavy, so the overall frequency of events should incur. But we will have breaks in those past events. It actually got up into the 80s in January and dried out and got sunny. Don't freak out. It'll probably change again and go back to those stormy conditions. The elements of weather variability will still be at play here. The snowpack, we'll see. We've had great snowpacks with these, but these tend to be warm events. They tend to have higher freezing levels. So that's going to be something we'll pay attention to over the course of the year. And the connection between sort of flooding and our concern for floodings is really a mixed bag here because the past El Nino events that have given us flooding have been largely related to tropical storms occurring this time of year or the year after the El Nino event. So the big flooding event that gets attached to the 1982-83 event actually happened the year after. It happened in October of 1983, well after the winter rainy season. So for flooding on the big rivers here, it's all about antecedent conditions. And so if we have a great wet winter and we still have lingering tropical storms next fall, that's when you end up having the trouble. It's not necessarily in the middle of the winter we're still moving out of drought. So I think that California and us, we don't have a lot of flooding concerns. There could be instances where fire scar areas can have trouble, but we just don't have wet enough soil now to cause, I think, big, large-scale problems at this point. This continues over the next couple of years, like we had in the 80s. That's when you start thinking about this connection between El Nino and flooding. Okay, so for Christmas this year, I found this online. If you're shopping for a Godzilla-themed gift, I found this one. I thought this was great. And I think I'm right at the hour. And thanks for your attention. And hopefully no nausea induced with all the colors on the graphs here to go for. So thanks so much. Any questions? Stunned everyone. Okay. Yes, absolutely, Doug.
Is there any correlation between so-called atmospheric rivers and landfall?
That's a great
Good question.
Is there any correlation between atmospheric rivers and ENSO? The correlation is that typically atmospheric rivers usually form during La Nina events, and typically La Nina or ENSO neutral events, and typically impact sort of further north of here and through California. So they're often related to what we call the Madden-Julian oscillation, and the Madden-Julian oscillation becomes weak, if not non-existent, during El Nino events of this magnitude. So instead, what you get is this